Now, to wrap up this chapter, we're going to compare interfaces and abstract classes. They have some similarities and some differences. In an interface, all of the data has to be constants, but an abstract class is allowed to have any type of data. Interfaces do not have any method implementations. They only have method signatures, whereas abstract classes can still have concrete methods, although they may have abstract methods as well. This is captured for you in a lovely chart at the bottom of this slide, where we compare on two rows, the first row abstract class and to interface on the second row. So in terms of variables, we don't have any restrictions in terms of abstract classes, but in terms of interfaces, all the variables have to be public, static, final. And remember again that because that's true, you don't actually have to specify it. The compiler will infer it if you leave it out. In terms of constructors, constructors are going to be invoked by subclasses either through instructor chaining or directly, and abstract classes are not able to be instantiated using the new operator. With the interfaces, there are no constructors, and interfaces can also not be instantiated using the new operator. They can only be implemented by other objects. Finally, methods for abstract classes, there are no restrictions on them. We could have a combination of abstract and concrete methods. Whereas with interfaces, interfaces may contain public abstract instance methods and public default and public static methods. Continuing our comparison of interfaces and abstract classes, it turns out that, as you know, we do not have multiple inheritance in Java. We only have single inheritance, which means a class can only extend a single superclass. But in terms of interfaces, it can implement as many interfaces as it wishes to. We also learned that all objects ultimately inherit from the object class, making the object class a single root that's shared amongst all other classes. That doesn't happen with interfaces. There's no such thing as a particular single root for interfaces. We learned that a class can define a type, and it turns out an interface can also define a type. And finally, variables of any interface type can reference any instance of a class that implements that interface. To continue our summary of interfaces and abstract classes, interfaces can inherit other interface using the extends keyword. And when we do that, we say that an interface is a subinterface of the first. And an interface can extend many interfaces. So to do that, we would say public interface and give the name of the new interface, and then say that it extends interface 1, comma, interface 2, and so on. So in other words, a comma delimited list of interfaces is possible. In this case, if a class implements the interface that we're talking about, in this case, new interface, it needs to implement all of the abstract methods in new interface, but it also has to implement all of the abstract methods in all of the interfaces that new interface extends as well. Finally, whereas an interface can extend other interfaces, it is not able to extend a class. We see here a very general UML diagram that helps capture some of what we've talked about in the past few slides. So let's very carefully look at this. The root object class is object that you see on the bottom left corner there, and all classes inherit ultimately from that because that is the root class. So class 1 inherits from it or extends it, and class 2 extends that. So there's an inheritance relationship between those three boxes on the bottom. That implies an is-a relationship as well. So class 1 is an object. Class 2 is a class 1. Notice the dotted lines do not represent inheritance, but rather represent implementation. So right in the middle from the box at the bottom that says class 1, you see a dotted line going up, and this indicates that class 1 implements interface 1. Interface 1, on the other hand, implements both interface 1 underscore 1 as well as interface 1 underscore 2. As a result, class 1 effectively implements both of those interfaces too. So class 1 is an instance of interface 1, interface 1 underscore 1, and also interface 1 underscore 2. Class 2 is even more complicated yet, because whereas it directly implements interface 2-1 and 2-2, it indirectly implements interface 1, which in turn indirectly implements interface 1_1 and 1_2. So every single interface that you see in this diagram is implemented by class 2. So that's a fairly complicated in general example of what can happen. Notice once again then, class 2 would have to be responsible for implementing all of the methods in all of those interfaces. Otherwise it wouldn't be a concrete class. So to wrap up chapter 13, we have a question here, whether we should use an interface or a class. And the guideline for this is to think about the relationship between the two. If there is a strong is-a relationship that very clearly describes a parent-child relationship, then that should be modeled using classes and inheritance. So for example, a student is a person, and so that relationship is best modeled using inheritance. The relationship in the case of an interface is weaker, and we call it an is kind of relationship, indicating that the object possesses a certain particular property. So it's a weak is-a relationship that would be modeled using interfaces. An example of this then is the string class. It implements the comparable interface, meaning that all strings are then comparable. They have that property. We wouldn't say that it extends the comparable interface, because it's not the case that a comparable is a class, or that a string class is a comparable, but rather we are simply describing a property of strings, and in that context it's better to think of the comparable interface as an interface, not a class.